Alright, welcome back to another demonstration of orbital dynamics calculations. Today I'm going to cover perturbations. As you can see, this section here under column Z on the satellites tab specifically shows some of the perturbations, whether you're propagating using two-body effects only, perturbations including J2 and J6, and the drag terms, either B star or the derivatives, depending on what you want to select from the TLE. If drag is unchecked, it won't include drag calculations at all. It also includes J22 effect and third body effects, specifically the sun and the moon. So we're going to go back here and click run and hit single again, and once it generates it and gets moving, we'll go back, revert, and there we go. That's where the ISS is right now, right off the boot of Italy. Okay, now say we want to see some of the third body, or I'm sorry, the two body effects. I'll hit two body, and there you go. You can see it skipped. That's the effect of only two body effects, basically just the Earth and the satellite with no perturbative effects. We're going to move it back, and then you can see what that looks like. There you go. Now another option, and you can play around with all these things. These ones down here in the bottom really don't make that much of a difference. You can play around with them if you like. Another option here is if you check Analyze Orbits, it will then run through 4 different options, kind of a conglomeration of all of these. I'm going to go hide the ISS, go back to the desktop because it created a new KML orbital analysis. And there you go. As you can see, it generated the satellite 4 times based on 4 different perturbations. ISS here is the two-body propagation. If you pull it down, you can see which ones I'm talking about, the orbit colors. Red is two-body propagation. Blue here is the J2 for argument of perigee and right ascension and ascending node. The J6 effect is the green, and J6 plus the drag, J2, 2, and third body effects. There's a big difference between two-body and including perturbations. There's not a huge difference, as you can see, between all the other perturbation effects. But it provides an interesting way of looking at the satellite so you can determine, useful information. So what I'm going to do is go back here, and we're going to choose real-time multiplier option again, because what we want to see is how this changes over time. We'll choose 720 times real-time multiplier, and now it's going to generate 720 times real time. What it does is it shifts the orbit, and if you were to watch this continually for a while, it will widen and narrow the orbit depending where you're at, but ultimately over time it will separate significantly. This is just some of the options that you can use with the spreadsheet. So we're going to go back, uncheck Analyze Orbits. We don't necessarily need that anymore. Go back here to the left, turn off the real-time multiplier, bring it back to 1, click Stop, and that concludes today's demonstration. Thank you.